So again, from this place, they give us a couple of options. The first one was -4, 0. If we put in a -4 here, this is going to come out to be a 0, and 0 times 3 is just 0, and that's why we get this digit here. That was option F. Option G says when x is 4, y is 0. So let's put in a +4 in here. 4 minus 4 is still 0, and 0 times 3 is 0. So that's why at the end we get a 0. In other words, option G, 4, 0. The output will be 0. Again, with our equation here, we can try when x is 1. So the 1 minus, or the 1 plus 4 rather, is 5. 5 times 3 is 15. And that's what we see right here. When I substitute in a 1 for the x, I get out a 15. Now let's work on our 2. So if I put in a 2 here, 2 minus 4 is 2. 2 times 3 is 6. So the answer here should be 6, but they list the answer for y as 2. And that's why J is your answer, because that is the one point that does not work on the graph. Which point cannot be on the graph? And it's this one. When you substitute it into your equation, you get up that this should be the coordinate point 2, 6. All right, the very last one. A biologist caught, measured, weighed, and they released 8 fish of the same species. The table shows which equation most accurately models the data. Okay. So we can see here probably where the y-intercept is going to be will be a positive number probably, because here is y of 0.7, x is 13. So we're out here at x is 13 and y is 0.7, like right here. So where are we going to cross the y-axis will probably be somewhere down in here at the bottom. Right here. So that we still hit this first coordinate point. We're going to hit the second coordinate point at when x is 15.5 and y is 1.1. So we'll say this is 15.5 and this is maybe 1.1. So our line kind of looks like this. I think that negative 0.29 and negative 3.2 are really good starting places to estimate our y-intercept. So I'm going to go ahead and cross out D and A. D and A both have positive y-intercepts, and just from the chart, when we kind of sketch out a graph, it doesn't work. It can't be a positive y-intercept. It needs to be a negative y-intercept. Let's take a look at the slope. The slope is just going to be rise over run. So that is the distance between y divided by the distance between x. So the distance here, 0.7 to 0.1 is 0.4. And then over here we have 13.1 to 15.5. And that is a total distance right there of 2.4. So we can move the decimal over 1, and we can have something like that, where we have 4 divided by 24. That's an easier fraction for us to reduce, because 4 and 24 goes in just about like 1 and 6. And that's how we're getting this fraction for the slope. Because over here, in our other answer option, our slope is a positive 3.2, so our fraction would have to be way bigger for it to come out like this. So over here, we're thinking this has got to be the best estimate. It most accurately matches. Option B.